Greetings everyone, welcome to Side A, Side B. In this video, a continuation discussion on how the periodic functions are derived from the unit circle. The overall plan: discuss two items, plotting a graph and proving an identity. Hey, so what's in our toolbox? How about what we know from the Pythagorean theorem? First, a discussion on plotting the entire unit circle on a graph as a wave. Our first blackboard, please. In our last video, we plotted 5 points in red from the unit circle on a graph. Let's see if we can mathematically plot the entire unit circle. First, we use what we know from the Pythagorean theorem. The only right triangle that will have angles P and W equal each other is when both angles are 45 degrees. So what is side C when A and B are the same? Say, the number 1. Let's solve for C. Make the substitutions. We get the blue box. C equals square root 2. Let's see what we get when we divide each side by square root 2. For blue 1, we get side C equals what we want, the number 1. Then we get blue 2 when we rationalize 1 over square root 2 to get square root 2 over 2. We now have values for the sides of our triangle we can work with because side C equals 1, the radius. Now the sides A and B and C make the triangle Z. It follows cos theta equals square root 2 over 2. Then let's plot a point between the values 1 and 0. Going counterclockwise again, we plot point W on the unit circle with the red arrow, then plot its cos theta value on the graph. See that? Now let's plot a point between the values 0 and -1. Then inscribe triangle Z in the unit circle in the following way. In the next quadrant, now cos theta equals negative square root 2 over 2. We plot point W on the unit circle with the red arrow, then plot its cos theta value on the graph. Now let's plot a point between the values -1 and 0. Then imagine inscribing triangle Z's reflection in the unit circle in the next quadrant in lavender. Then cos theta equals negative square root 2 over 2. Then we plot W on the unit circle with the red arrow and plot its cos theta value on the graph. Here you might be asking, how can the same value of cos theta equal a different angle? Very good question. But obviously, we can inscribe triangle Z in lavender in the following manner. Would you agree? If so, for now, just know we can make a sum 180 degrees plus 45 degrees, which equals 225 degrees, which is the other angle on the unit circle that corresponds with the value negative square root 2 over 2. Like we said before, our study of trigonometry is going to be a work in progress because there's a lot to roll out. Let's see if we can use what we already know to get a result. Now let's plot a point between the values 0 and 1. Imagine inscribing triangle Z's reflection in the unit circle in the next quadrant in lavender, so that cos theta equals square root 2 over 2. Then we plot W on the unit circle with the red arrow and plot its cos theta value on the graph. You might be thinking again, the same value of cos theta equals a different angle again. We hear you. And we'll just say we can do the same thing as before. 315 degrees is the other angle on the unit circle that corresponds with the value square root 2 over 2. But we can plot its reflection. For now, that's all we need to know. When we elaborate more in another video, the values positive and negative square root 2 over 2 coincide what are known as reference angles. Returning to our original triangle Z, Let's see if we can plot the entire unit circle on a graph in terms of cos x. If we let a equal x, then we have x squared plus b squared equals 1. It shows in the blue box. For any value x, we can solve for b all day long. Let's see how we can do that. For example, letting x equal square root 2 over 2, solve for b. Apply the square. 2 over 4 equals 1/2 plus b squared equals 1. Subtract 1/2 from both sides to get b squared equals 1/2. Square root both sides. B equals plus or minus square root 1/2. Apply the square root, then rationalize. We get as expected. B equals plus or minus square root 2 over 2. Nice. Notice the orange arrow on the unit circle and its reflection, the lavender arrow, which is the pair cos and sine theta. However, to be clear, the arrows on the graph are the values of cos x. Observe cosine is positive on the circle and graph. We do the same for x equals negative square root 2 over 2, then solve for b. Again, we get two values for b. The pair is plotted on the unit circle. Again, their reflection is the lavender arrow. The arrows on the graph coincide with the values of cos x. This time, both points of cosine are less than 0, which obviously make them negative. Let's choose a value for x close to 1 as the following, then solve for b, which means we need to make use of a calculator. So giving some credit to Mathway returns the following two pairs of values. Again, observe the orange and lavender arrows on the unit circle and where the values of cosine land on the graph. Both are positive. Next, letting x be negative and close to 0 as the following value. Then solve for b. Using Mathway again, returns the following pair of values. The orange and lavender arrows show where the pairs land on the unit circle and where the cosine values land on the graph. There's for sure a lot to unpack about periodic functions. Hopefully it's starting to make some sense and you're getting something out of it, because doing studies like this also helps our channel. Or maybe go get a coffee, because here's where we're at.
Yes, it's coffee time! Cappuccino!
We'll be back very shortly, ladies and gentlemen. Alright, welcome back. Let's continue. Actually, after all that, we're almost there. All we need to do to find the domain of x in the white box, letting x be less than or equal to 1 and greater than or equal to 0, and its reflection, then is plotted on the graph. Lastly, all we need to do to find the domain of x in the white box, letting x be less than or equal to 0 and greater than or equal to negative 1, and its reflection, then is plotted on the graph. Observe, both arrows on the unit circle and the graph are moving towards negative 1. Very nice. While there's still more to unpack, like a discussion on radians and degrees, for another video, for now, just by knowing what we know, like varying the orange triangle, which automatically varies its reflection, it's shown as possible to plot all the values of cos theta from the unit circle on a graph as a wave. On that note, a proof of the Pythagorean identity, as it were, claiming the bonus identity prize. Let's begin. Welcome back. Indeed, the relationship between the Pythagorean theorem and the unit circle returned a bonus identity, which you might know helps to solve problems. In an upcoming video, we'll use it to prove a theorem. First things first though, let's claim it, do a proof. And actually, we're ahead of the game. In our last video, as it turned out, we did the scratch work for the proof. Ladies and gentlemen, as usual, we want to prove the white box. Cos squared theta plus sine squared theta equals 1. Next, recall the blue box. Cos theta equals A over C, sine theta equals B over C. Now sometimes the sides are written where side B is side A, The same can be said for side A. It really doesn't matter, but probably for consistency, side C is always labeled side C. We label side A such as it is because cos theta is written first in the pair for a clear line of thought. Now consider the Pythagorean theorem, which we proved in a previous video, a squared plus b squared equals c squared. Next, let's divide each term by c squared. The terms on the left can be rewritten as a over c squared plus b over c squared equals the right-hand side, which is just the number 1. Making the appropriate substitutions, the result gives the white box. We are done. Nice. See that? What did the relationship between the Pythagorean formula and the unit circle return? Points on a graph which led to plotting a wave and claiming a bonus identity prize. Not bad. But what about the wave of sine x? Since sine x is really a reflection of cosine, just replicate the study we just did. So, consider it done, so we can save some work. Be that as it may, there needs more discussion on arc cosine and arc sine, also radians and degrees, and how our two waves can be turned into periodic functions. Since it's logical, an end reflects an end. Until next video, ladies and gentlemen. You know you want to say it. Cappuccino, coffee time. Yeah, something like that.